Exponents and square roots. Another thing that you probably haven't dealt with for a very long time, but another one of the things that really you are going to have to commit to memory. I'm sorry, today's really a commit to memory day. Remember, you can do practice questions on Grocket afterwards. So your rules of exponents are as follows. So we have general rules, first off. So first off, anything to the 0 power is always going to be equal to 1, even 0 to the 0 power. So anything to the 0 power is equal to 1, whereas anything to the first power is just equal to itself. 2 to the first power is 2, 100 to the first power is 100, x to the first power is x. Those are relatively easy to remember. We also have rules for adding exponents. If you have, oops, I shouldn't have done that. Let's go back one. So if we have x squared plus x cubed, those are the other words for x to the second power and x to the third power, this just equals x to the second power plus x to the third power. You cannot add these two together to somehow get 2x to the fifth. You don't multiply the things together to get 2x to the sixth or just x to the fifth or anything like that. All of those are naughty. You just have to leave them alone. If they have the same base and different exponents and you're adding them, you leave it. Multiplying them, on the other hand, you don't leave them alone. When you're multiplying two exponents of the same base together, you add the exponents. So x to the x squared times x cubed equals x to the 2 plus 3, which equals x to the fifth. If ever you're unsure about this and you're saying, oh, Jim, and the chin stroking is optional, Jim, I don't know about that. I don't think I can remember that. You can always write it out with small enough numbers to kind of re-verify for yourself that this is right. So x squared is x times x, and we're multiplying that times x to the third, which is x times x times x. So that's our x to the third right there. This is our x squared right here. Multiply them the two together, we have 5 x's. That's x to the fifth. Pretty cool. Now when you raise exponents to exponents, that's when you finally, people have been itching to multiply these exponents for a while maybe, when you raise an exponent to an exponent, that's when you multiply the two together. So this becomes x to the 2 times 3, which equals x to the sixth. And again, that's another one that you can write out when the numbers are small. So it's x squared cubed. So here's one x squared, here's another x squared, and here's our third x squared. When you multiply all of these together, that's 6 x's, it's x to the sixth power. Finally, dividing them, so x over y to the third power, you aren't really doing the division at this point, but this can be rewritten x to the third times y to the third. So that may end up being helpful in solving a particular problem. And it may be also helpful to go in the opposite direction. So just know that you can do that little conversion. Finally, when you are dividing an exponent by an exponent, you're kind of factoring things out. So you're actually subtracting these exponents from each other. This is x to the 2 minus 3, because you may recall that like x to the negative 2 is 1 over x to the x squared, x to the second power. So x squared over x cubed is x to the 2 minus 3, which is x to the negative 1. And remember, negative powers are not necessarily negative numbers. X to the negative 1 is equal to 1 over x, or 1 over x to the first power. Whoops. All right, so using those rules, putting them into effect here. Remember how I mentioned that dividing by 0 is naughty? When you see problems that say if x does not equal 0, that's probably, if they give you something that x does not equal, they're doing it so that they're not dividing by 0. Note that if x did equal 0, x to the fourth power would still be 0, and we'd have 0 in the denominator, which is naughty. So the GRE and Grocket seek to avoid breaking the laws of time and space by dividing by 0. So we will go out of our way to avoid it. We can, however, follow our other exponent rules here. So first off, we raise these guys to exponents. X squared to the third power, we multiply the exponents. This becomes x to the sixth times x to the fourth times x squared. And you could do one of two things. You could add all of these up and then subtract this, or you could recognize that these two guys vertically, an x to the fourth up here and an x to the fourth down there, will cancel each other out, and we're left with x to the x squared times x to the sixth. When you multiply two exponents of the same base together, you add their exponents, which equals x to the eighth. So this is x to the 6 plus 2. And there we have it, choice D. Finally, your rules of roots, very important. As important, possibly even more important. No, I'd say they're about equally important as the exponent ones, and so something else you should devote to memory. Remember that the square root of something, let's start with this one down here, this will probably be easiest. The cube root of x is equal to x to the 1/3 power. So note that square roots can be converted to regular, like, little number exponents as much as you want, and sometimes that makes life easier. So the square root of something is equal to x to the 1/2 power. All right, so when you square a square root, you basically undo the square root. So the square root of 2 times the square root of 2 just equals 2. The square root of x times the square root of x equals x. On the other hand, if you add them together, you're not undoing the square root, you're just creating more of the square roots. Square root of x plus the square root of x equals 2 times the square root of x, because, hey, look, there's 2 of them. Again, when you multiply roots together, it helps to turn them into those exponents. The cube root of x is equal to x to the 1/3 power, and that's times x to the 4th root of x, which is x to the 1/4 power. And remember, when you have two exponents of the same base, and you are multiplying those exponents together, you add the exponents together. So we need a common denominator. Remember, we covered fractions also. So 1/3 plus 1/4, we need a common denominator. That's going to be 12. So this is 4/12 plus 3/12 equals 7/12. So this is going to equal x to the 7/12. Crazy, huh? Finally, when you raise exponents to exponents, you probably still want to convert them to fractions. So again, this is the 4th root of x, which is x to the 1/4, to the 3rd power. And when you raise exponents to exponents, you multiply them. So this is x to the 1/4 times 3, which equals x to the 3/4. Memorize these, commit them to memory, put them up on next to the bathroom mirror or by your pillow at night so you see it first thing when you wake up in the morning. Until you have these down cold, they really are important for the test. So here's an actual problem. Q is an integer and also the square root of p. Then which of the following is also an integer? So we have q equals an integer, and we know that q is the square root of p, so q times q equals p. And an integer times an integer is also is always going to be an integer, like 3 times 2, 4 times 5, whatever. As long as both of these are integers, and we already know they are, then we know that p is an integer. So which of the following is also an integer? Indicate all of them. And if you're not sure about this, go ahead and pick numbers. Just say that q equals 2 and p equals 4. Q is an integer, and it's the square root of p. So just pick numbers, and then well, p over q. P over q is 4 over 2, which equals 2 over 1, which is an integer. So there's 1. Q over p, that's 2 over 4, which equals 1/2, which is not an integer. The square root of q would be the square root of 2. That's not going to work. But the square root of p we already established is q. We already knew that that was an integer, so d is also definitely an integer. So finally, your strategies for these exponents and square roots, notorious for traps. Just even just in the difference between raising an exponent to an exponent and multiplying two exponents of the same base, that's the most common one. So watch out for those. When in doubt, try to rederive the rules with simple numbers. Default to what you do know. You can even write it all out this way if you need to, or practice it with real numbers on your calculator. So you do that. Know your calculator ahead of time, so practice things that use the calculator like it is on the actual test. Positive fractions, this is one of the traps or the exceptions to rules. When you raise a fraction like 1/2 to a higher power, it becomes smaller. $500,000 is a bigger amount of money than half of $500,000, which is a higher power of the fraction 1/2. So note that they get smaller. Note that negative numbers alternate between being positive and negative. If x equals -1, let's just say, x squared is -1 times -1. Negative times negative is positive. X squared equals 1. X cubed equals -1. X to the 4th goes back to being 1 again. So just know that negative numbers behave in funny ways when they're the base of the exponent. The square root of 4 is 2, not plus or minus 2. So the radical sign here always means the positive square root. Always, always, always on the GRE. On the other hand, like we give here, x squared equals 4. This is x equals 2 or negative 2, because either one of these squared becomes 4. So just keep track of the difference. And then finally, fractions negative 0 and 1 to test particular statements relating to exponents.